Two slits make an interference pattern with 550 nanometer light on a screen that's 4.5 meters away. The distance separating the third order fringe on the left from the third order on the right is 5.147. Dear Lord. Okay, so if we look at this interference pattern, here's the central bright spot. Here's the first order on one side, the first on the other. The second order fringe and the second order on this one, right? Okay, the third order fringe and the third order fringe, right? And they're saying that this entire pattern is 5.14 centimeters. All right. I'm gonna say, you know what I'm gonna say? I'm just gonna cut this in half because my brain works better this way. I'm gonna look at this side, and this side is 2.57 centimeters, right? Let's just double check that. It's half of 5.14. Yeah, 2.5. Okay, my brain can work a whole lot better with just half of this thing. So 2.5 centimeters is the width of half the pattern, right? Okay, so we can do this. Let's use the approximate formula first. Let's see if that works. Okay, so that means that one of these little dots on the screen, we can just divide that by 3, right? So divide that by 3. And I get that this S, when I do that, that is 0.856 bar centimeters, okay? And then lambda is this, right? So I'll plug that in for lambda. 4.5 is how far away this screen is. So we got to be able to solve for d. Let's do it the easy way. Okay, so 0.856 bar is equal to 550 times 10 to the minus 9th times 4.5 divided by that gosh darn slit separation. Okay, so it's going to be this times this divided by that guy. All right, 550 times 10 to the minus 9th times 4.5 divided by the number I just got. Oh, this is going to give us that in centimeters. Do we want that? Okay, I'm going to make this 0.00856 bar. And now it's meters, okay? So I'm going to put a couple zeros in here, okay? Because now I really want to do it in meters, otherwise I'll get too confused, okay? Let's try this. And I get that the distance is 2.889 times 10 to the minus 4th meters, which would be 0.289 times 10 to the minus 3rd meters, which would be 0.289 millimeters, because that's the same thing, right? Okay. That works. Obviously, we could also do this with the angle formula. Okay. If you really want to see that, you can keep watching. I'll do it with the angle formula if this whole thing kind of bothered you. Okay. So I'll do it with the angle next. Okay. So again, we're going from the center to first order, second order, third order, right? If it went from one side to the other, and it was 5.14, this is 2.57, right? And that angle is, in fact, the inverse tan of 0.0257 over 4.8. Because I know you like maths and trigonometry, so let's do this. All right, point inverse tan. I'm doing like here. I'm doing this. Okay. This side is 2.57 centimeters. This side is 4.5. I'm doing inverse tangent of opposite over adjacent. Okay, so 0.0257 divided by 4.5. Whoops. That angle legitimately is 0.3272 degrees. Now we can plug into this, right? Okay, this is the third order fringe, so we're going to go 3 times 550 times 10 to the minus 9th equals d that we don't know, sine of the angle that we do know, right? Okay, so I'm going to go 3 times 550 e minus 9 divided by the sine of and I get that D is legitimately 2.889 times 10 to the minus 4th meters, which is 0.289 millimeters. Okay. You know, you can do it both ways.